Hello everyone, today we're going to be looking at a 2011 Ford F-150 with a charging system fault. So this vehicle is a 2011 Ford F-150 3.7 liter V6, the non-turbo. Customer states that the charging system indicator is on and that the instrument cluster is turning on and off. Confirmed that when you start the vehicle, the battery indicator light does come on, and the alternator does seem to flicker on and off. It'll shut off for long periods of time, and then it'll come back on and flicker on and off. So I'm not really too sure what that's about, but I guess we're going to have to, the first thing to do is we're going to have to scan it for codes. Now we're going to have to scan in the PCM, and it might not be a bad idea to scan in the cluster as well, just because we are having issues with that. So we're going to perform a key on engine running self-test in the PCM, as well as a continuous memory DTC test in the cluster. So after scanning the PCM, we did find a P0625. It is a current trouble code. ODDTC is on-demand DTCs. Generator field terminal circuit low. That AC demand beyond self-test range, we're going to ignore that for now. They usually set there if you don't turn the AC on while it's doing its self-test, so no big deal with that code. Now, after scanning the instrument cluster, we did find a system voltage high code. So that kind of coincides with our charging system fault. It might be related, so we'll have to keep that in mind. We're going to have to figure out what these descriptions mean here. The P0625 and the P0563 looks like P0625 sets if the Gen Mon circuit is shorted to ground, the A sense circuit is open, or the B plus circuit is open. P0563 sets if the module that it sets in detects a voltage from the charging system higher than 15.2 volts. Judging by that last code there, I think the next step we should do is just check the system voltage just to see what it is. So after checking our system voltage, we found that this thing is way overcharging at almost 17.5 volts, which is way too high. So this is actually what's causing the cluster to shut on and off. I have found this out on other vehicles. I can't find anything in the service information that describes this, but I have found that on every other Ford that I've worked on that has had a high charging voltage concern, it will shut modules down to protect them. It's kind of like an over voltage protection mode. I can't find any information on that in the service info, but that's just from my experience what I've found. So now we have to figure out what could be causing this this high voltage concern. And in order to answer that, we need to know how this charging system works. So after looking at the description of the description and operation of the alternator, I found that the GenCom line communicates the desired set point from the PCM to the alternator. The GenMon line communicates the generator load to the PCM, and the A-Sense circuit is used to monitor battery voltage. Now, to help explain this a little better, we're just going to take a look at the alternator wiring on the next screen. So as you can see, that blue circuit is the GenCom circuit. The violet is the GenMon, generator command, generator monitor. And the gray and red one above those two is the A-Sense circuit. So to put it in simpler terms, this vehicle has a PCM-controlled alternator, and it uses this generator command circuit to command the alternator onto a specific level. This GenMon circuit is basically a monitor circuit where the alternator tells the PCM how hard it's working, and this A-Sense circuit is the alternator's way that it monitors battery voltage. So a fault in the GenCom and GenMon circuits generally will not cause an overcharge condition. If there's any sort of fault in those two circuits, the alternator will either stop charging or the alternator will default. And in that case, it'll self-excite and charge at a default of 13.5 volts. An alternator will overcharge if the A-Sense circuit is open or shorted. The alternator monitors system voltage on the A-Sense circuit and monitors command from the PCM at the same time. If the ascent circuit is lower than the command voltage, the alternator will ramp up until it meets command voltage. So basically, if it's monitoring that ascent voltage circuit, and if it's lower than what the PCM is commanding it to, it's going to ramp that voltage up until it meets that command from the PCM. So basically, we're going to have to go and check this ascent voltage first to see if it's shorted to ground or an open circuit or something like that. Because if it can't get any voltage to that alternator, it's just going to either read low voltage or no voltage and think that the vehicle's battery is dead and just ramp voltage right up, trying to compensate. Here we have our ascent circuit that we're going to have to check. I'm going to throw our voltmeter on there, and our reading is 1.4 volts. That kind of explains why our alternator is charging so high. It only sees a 1.5 volts on that circuit and thinks that the battery voltage is low, and is ramping the battery voltage, or ramping the charging voltage right up. The ascent circuit is low. Alternator thinks battery voltage is low compared to PCM command, and therefore the voltage output is very high to try and meet PCM command. We're going to suspect that the ascent circuit has a high resistance issue. If we were reading no voltage or something like that on that circuit, then we may think it's got an open circuit or something like that. But in this case, there is a little bit of voltage there. So it kind of looks like we have a high resistance issue in that circuit. The next place to check is going to be at this fuse. It's just up from the alternator in the battery junction block. It's the easiest place to get at to check in the circuit. So we're just throw our voltmeter on there, and we measured 17.5 volts, so essentially battery voltage. That pretty much tells us that we have some sort of high resistance in our ascent circuit between the battery junction box and the alternator. Measuring battery voltage at the ascent circuit fuse tells us we have high resistance between the alternator and ascent circuit fuse. After doing a little bit of digging around with this vehicle, I was actually able to find the fault. It was pretty glaring, actually. Someone had been in here previously and done an improper repair on this vehicle. It looks like they took the ascent circuit coming right out of the alternator here and just connected it to a fuse jumper lead and connected it right to the voltage output post going to the battery, which essentially does the same thing as running a wire to the battery junction block, but it leaves this fusible link out in the open here, susceptible to moisture. And that's pretty much exactly what happened to this vehicle. It took the fuse out, and it was just covered in corrosion. Now, just to confirm, I did throw a different clean fuse in there. Battery light went out and it started charging normally. So to get down to it, a previous repair on this vehicle to the ascent circuit was made and was not done properly. The fuse had rotted out due to the repair being left out in the open, leaving it susceptible to moisture. After I confirmed that putting the good fuse in there basically made everything work properly, I disconnected all that stuff there, and the proper repair was made by running a new wire from the alternator connector to the ascent circuit wire at the battery junction box. When I did that, battery charging voltage again returned to normal and the battery light went off. Customer was happy and the vehicle was fixed.